Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Seychelles by Blobs, and here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit from 1 through 9 such that there are no repeats in any row, column, or designated 9-cell region. We need to divide the grid into a number of islands, which are orthogonally connected groups of cells. Every island contains a single circle digit, and the digit in a circle indicates the number of cells making up the island. What is an orthogonally connected group of cells? Well, this is an example. It means you can go from any cell in the orthogonally connected region to any other cell in the orthogonally connected region just by going through edges, all while staying within the region. So, for example, to get from here to here, you can just go through these edges, and that would be valid. What is not valid as an orthogonally connected region would be something like, say, this. This is not valid as an orthogonally connected region because from these two cells, even though they can go to each other by going through edges while staying within the region, they cannot get to the other cells in the region by doing so. They would have to either go through a corner or they would have to go through an edge and exit the region, which is not allowed. So, and this is a potential valid example of the island because it has 6 cells on the island. It has a single circled cell on the island. And yeah, 6 is the number of the cells on the island, and that matches the 6 in the circled cell that's with that island. So that's an example of how islands work. The islands are surrounded by a waterway, a single orthogonally connected group of cells. So that would be, for example, like this is, I guess since this is Seychelles, this would be the Indian Ocean here. And the orthogonally connected group of cells applies to all the water cells. So the water cells forms one single orthogonally connected group of cells. So it's the same thing as this smaller example, except that it applies to all ocean cells, essentially. All caged cells are waterway cells, and the digit in a caged cell indicates how many waterway cells are seen orthogonally from that position, including itself. Island cells block vision. So, for example, say we did have something like this, and say we had, these were waterway cells. This doesn't really work, but let's try that. These are waterway cells, and this would be island cells. And then we have waterway cells here, or whatever. We know this cell only, so how many cells does it see orthogonally, which is just horizontally and vertically? It sees itself, it sees this one, and that one. It's blocked by seeing other cells from these island cells, so it would not see that. So in this case, it would only see 4 cells. So it would have to have a 4 in that caged cell. And that's an example of how caged cells work. We also have waterways cannot form any 2x2 area. So we cannot have a 2x2 area that is all water cells. So for example, this could not be a waterway here as a 2x2 because we have a 2x2 area that's all waterway, and that's not allowed in this puzzle. Finally, digits do not repeat on islands. So as an example for this island, we cannot have another 6 here because we have a 6 already on the island. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, this is an island. Well, let's color all the waterways. Those are all water. We have a 2x2 area here, which is all water, so this cannot be water, it's land. This one is only a land island by itself because it's size 1, so therefore these must be water. This is size 2 island, so this must be land, and therefore this must be water here. 6 has to go out because it has to be at least size 6, and therefore it has to go to there at least. 9 is not, we don't know if that's a water or a waterway. Okay. This is land. So all the circled cells are lands. This sees only 1, 2, 3, 4 waters. So this is 4. This currently sees 4, but it cannot be 4 because of 4 in the box. It has to see, it can't be 5 because of 5, sorry, 4 in the column. Can't be 5 because of 5 in the box. I was seeing that. So this must be at least 6 waterway cells that it sees. So these are water. This is a 2x2 area that has 3 water, so this cannot be water, it's land. This cannot orthogonally connect because then it would be an island with 2 circled cells. So this must be land here, which forces that to be water there. This water must orthogonally connect, so it must go that way. So must this, it must go that way. This is size 3. This sees 3 cells that are waterway, so that's 3. This sees 1, 2, 3 right now. It must see more than that because we have 3 in the box. So it has to go here, blue. That sees 5 at least. So this is 5 or 6 cells that it sees. It cannot see 6, so therefore it must be 5. So therefore we see a land, must have a land there because we only can see 5 waterway cells here. This sees at least 6. This must see more than 2 because we have a 1 and a 2 in the column. So it has to be at least 3, so that's at least 3 there. This then sees 6 already. So this is 6, 7, 8, 9. This cannot see the same amount as this. And whatever is seen in this direction will be the same amount for these two. And these two are the same amount as these two. So if we have a green here, that doesn't work. Because if we had a green here, then these 2 cells would see the same amount of water cells. So this cannot be land, it must be water. We have a 2x2 area that has 3 blues, so this must be green here. This must see 1 more than this digit. This cannot be 5, so this can't be 6 here then. This is 7, 8, 9, which forces this to be 6, 7, 8. This sees either 6 cells, or if this is blue, it sees 8 cells, so this can't be 7. This must be 7. We have 1, 2, 3, 4, 5, 6, 7 at least. And if it's blue here, this has to be green. Because if we do have a blue here, the problem is this would see 8 cells then at least, which means this can't be. And if we try to make this, well, actually, that's not necessarily true. If we have green here, that does work. If we have blue here, it could be blue, blue. That is possible. And then this would be 3 greater than this one, right? And it would be 6. So that's possible. Okay. Hmm. This sees at least at least 6 cells. Sorry. So it's 6, 7, or 8. This is land. This has to connect orthogonally to some land 6 times, so it has to be 6 cells there. So this is blocked here. This is done as an island because you have 6 cells. We have two by 2 area that has 3 waterways, so this must be island. This sees at least 3 cells. So it could be 3, no 4, it could be 5, 6, but it can't see more than that. If this sees, well, could it? 1, 2, 3, 4, 5, 6, 7, 8, 9. No, can't see 1, 2, 3, 4, 5, 6. Would force this to be 7, 8, 9. It can't even see 6 cells. Because this can't be 9 because of 9 in the row. So this is 3 or 5. So we either have 3 here or we see 5. If this is 3 this way, that sees 6. If it's 5 this way, it sees 8 here. So this is 6 or 8. This then must see the same amount as this. If we have water here, the problem is this must be a 4-size island, but then it would have to connect with that, which is not allowed. So this cannot be water. This is land. This sees then 6 cells. So this could be 4 this way, which would make that water. Or it could be 4 this way. This sees 6. One of these is going to be connected. If this is water, this sees 1, 2, 3, 4 cells. It sees 1, 2, 3 extra cells, not including the one seen in this column. This sees 3 extra cells, not including the one seen in this column. So these would have to be the same digit if this was water. So this cannot be water. It has to be island. Right? Because it sees those 3 extra. This sees those 3 extra, but it sees the same amount in this column here. Therefore, this must be land. These cannot orthogonally connect, so this is water. We need 4 here. That's land. This cannot orthogonally connect because they are separate islands. So this is island, island here. This must be water. This must be island here to be a 5th island. We cannot go that way because that would force both of these to be island. This has to be water. This part does not orthogonally connect to the water unless it connects here. So this must go there. Therefore, this is island, and this is island. So that's a 6-size island. This sees 3 cells. So this is 3. This sees 7 cells in water, so that's 7. This cannot be island. Well, first of all, this is size 5, so obviously this can't be island. So that sees water. This currently sees 5 cells, actually. Cannot see 5 cells. It must see at least another This is a 2x2, that's all water. This can't be water, so that's island. This must orthogonally connect to the water, so that's water. This island is going to orthogonally connect to another island, so that's island there. This is 5 in size. It must be going out here. So this sees only 3 cells. So this is 3. This sees 6. This sees 4 island waterways. This sees 5. This sees 4 and cannot be 5 or 6 because of 5 or 6 in the row and column. So this is done as waterways that it sees. So this is 4. This is island. We have 1, 2, 3, 4, 5. That's done as an island, so these cannot be island cells. They're waterway. This must orthogonally connect, so that's island. We have 4 here. This sees 2 waters. This sees 5, 6, 7. So this is 5 that way. This sees 1, 2, 3, 4, 5, 6. This sees 1, 2, 3, 4, 5, 6, 7, 8 waters. This sees 4 water. This sees at least 5, and then could be up to 7. So, but it can't be 7 because of 7 in the box, so this is 5 or 6. This is 3 more islands here. We don't know where. Okay. Let's do remaining digits. Cannot be, it could be land, land, land. That is possible. Land, land, land is also possible. No, cannot be land, land, land. If it goes land, 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 this is water, which is not orthogonally connected to the rest of the waters. So we have 3 lands left. Cannot be that way. Can't be that way. So these are both land, definitely. And one of these 2 is land and one is water. Don't know which. Fives. Where is the 5s in box 7? Cannot be here or here, so it must be one of these 2. Where is the 5 then in column? Let's just not do that way. Let's go this way. What are the remaining digits in row 8? They have to be 1, 2, 7, 8. But this can't be 1 or 2 or 7 because of 1, 2, 7 in the column. So this is 8, which eliminates 8 in the rest of the row. Where is 3 in column 1? Can't be here because of 3 in the box. The rest are filled out, so 3 has to be here. Remaining digits in column 1 are 5, 6, and 9. Digits cannot repeat on islands, so this can't be 6, so this is 6 here. This can't be 5 because of 5 in a row, so that's 9, that's 5. Remaining digits in row 4. We have 1, 2, 7, 9. This can't be 7 because of 7 in the box. No 7 here because of 7 in the column. That's all we really have. Okay. Where is 3 in box 5? Can't be... Well, never mind. Remaining digits in row 6. We have 1, 2, 3, 8, and 9. No 3 here because of 3 in the box. No 9 here because of 9 in the column. Oh, where is 6 in box 6? Can't be here because of 6 in the row. Can't be here because of 6 in the column. Can't be here because of 6 in the row, so it has to be here. So this is 6, which makes that 5. That sees 5 waterways only. So we have water this way. This is land then, and this must be water. We're still doing normal Sudoku in this puzzle then. This has to be 1, 2, 8, and 9 remaining in box 4. The remaining digits in box 5 are 1, 2, 3, 7, 9. No 2 here because of 2 in the column. This can't be 2 because of 2 in the column. No 7 here because of 7 in the column. We have a guaranteed 7 in one of these two cells. This cannot be 4, 5, 6, or 3, so it's 1, 2, can't be 7, 8, or 9. Where is 3 in row 5? Cannot be here because 3 in the box, can't be here because 3 in the column, so 3 has to be one of these 3, which means this cannot be 3 anymore. Remaining digits of row 1. We have 1, 3, 4, 8, and 9. No 3 here because of 3 in the box. No 4 here because of 4 in the column. No 3 or 4 here because 3 or 4 in the column. Okay. Where is 7 in row 3? Cannot be here because of 7's in the boxes, and these are filled out, so 7 has to be here. Where is 7 in box 7 then? Cannot be here because of 7 in the column, so this must be 7 here, which makes this a 5-7 pair here. That eliminates 5 and 7 in the rest of the box, so this must be 6 and 9. This can't be 6 because of 6 in the row, so this is 9. That's 6. That eliminates 9 in the rest of the column. This can't be 9 because of 9 in the box. Remaining digits are 1, 2, 4, and 8 in box 1. That means we have a guaranteed 2 here, which means 2 cannot be here in row 2, so 2 has to be here in row 3. Okay, 3 eliminates 3 here in the rest of the column. We have, again, in column 4, the digits remaining are 1, 2, 7, 8, 9. This can't be 7 because of 7 in the row. Where is 7 in box 5? It must be one of these two. No 1 here because of 1 in the row. 4 in row 9 cannot be here because of 4 in the box. Can't be here because of 4 in the box. So 4 has to be one of these two because it can't be here because of 4 in the column. Where we have 8 6s. We know where the last 6 has to be. It has to be there. Where is 3 in box 3? Can't be here because of 3 in the row. Can't be here because of 3 in the column. Therefore, it's one of these two, which means this can't be 3 here. Where is 3 in box 6 then? It has to be there. Okay. Neither of these can be 4 because of the 4 in the column. So 4 has to be one of these two. Where is 4 in column 6? It must be one of these two. 4 in box 3 cannot be here. It could be any of these three, though. 5. Where is 5 in column 8? It must be here. That gives us 8 5s. We know where the last 5 has to be. 5 eliminates 5 here, so it's 7 and 5. Okay. We have all the 6s, 3s, we don't have enough information. 4s, we don't have enough. 5, we got that. 6s, 7. We don't have very much information there. 8s, we don't have very much information. 9s, we don't really have very much information either. And 1s and 2s are also not very informative either. Where is the 2 in box 8? Cannot be here or here because of 2's in the column and row. So 2 has to be one of these 2 digits, which eliminates 2 in the rest of the column. Remaining digits of column 8. 1, 2, 7, 8, 9. No 7 here, no 7 here. Where is the 7 in column 8 then? It has to be here. So that's 7, which eliminates 7 here. Okay. Remaining digits of row 2, we have 1, 2, 3, 4, and 8. No 2 here because of 2, no 8 here because of 2 and 8 in the column. This could be either, that's fine. Remaining digits of row 3, we have 1, 2, 4, 8, 9. No 4 here because of 4 in the column. No 2's here because of 2's in the boxes. No 9 here because of 9 in the column. This 9 also eliminates 9 there. Remaining digits of column 8, 7 are 1, 2, 4, 8. This can't be 1 or 4 because of 1 or 4 in the row. 1, 2, 4, 8. No 2 because of 2 in the row. Remaining digits of row 9 are 1, 4, and 8. This can't be 4 because of 4 in the column. Remaining digits of row 7, we have 2, 7, 8, 9. This can't be 2 or 8 because of 2 or 8 in the column. Okay. We are guaranteed on this island a 4 because 4 cannot be here. So therefore, this can't have another 4 on this island. Where is 4 then? Actually, we have a 1, 8, 9 triplet in row 3 and box 2. That eliminates 1, 8, 9 in the rest of the box and row. This can't be 1, 8, 9. It's 2. This can't be 1, 2, 8. So that's 4. 2 eliminates 2 in the rest of the column and box. 1, 8, 9 eliminates 1, 8, 9 here. So this is 3. This can't be 1 or 3. So it's 4. Therefore, there's no 4 here. 3 eliminates 3 in the rest of the row. Where is 3 then? This 4 eliminates 4 in the rest of the box. Where is 3 in box 3? It must be here. So that's 3. We have 1, 8, 9 as a triplet in row 1, which eliminates 1, 8, 9 in the rest of the row. So this can't be 1 or 8. It's 4. We are guaranteed a 9 here, so this cannot be 9 here, which eliminates 9 on the rest of this island, so this can't be 9 there. 8 eliminates 8 here, so that's 1, which makes this 7, which makes that 9. No more 1s here. It's 8 and 9. This can't be 1, 7, or 9. It's 3, which eliminates 3 here. Where's a 7 in this box? It must be here. So that's 7. There's no more 8s here. 1 eliminates 1 on the rest of this island, so this can't be 1. This is 8, 9 as a pair, which eliminates 8 and 9 in the rest of the box and row. This can't be 8, it's 1. This can't be 8, it's 1. That eliminates 1 from being here. 1 eliminates 1 from being here. This must be, these cannot repeat on the island, so this cannot be both 8 and 9 here. So this has to have a 2, which means this can't be 2. That's 8, which means this can't be 8. That's 2. 8 eliminates 8 here. So it's a 2, 9 pair on the island, which means this cannot be 9. That's 8, which makes that 9. 2 eliminates 2 here. This can't be 7 because of 7 in the column. 8 eliminates 8 here. 9 eliminates 9 here, so that's 2, which makes this 1. This can't be 1 or 7, it's 2, which makes this 8. This can't be 2, 8, or 9, it's 7. 2 eliminates 2 from these two cells. So where's the 2 in box 6? It has to be here. So that's 2, which eliminates 2 here, so it's 9 and 2, which means this can't be 2. So where's the 2 in box 5? It has to be here. Also, 9 eliminates 9 here, so it's 1 and 9. 1 eliminates 1 here, so it's 8. 1 eliminates 1 here, so it's 8 and 1. This can't be 1 or 8, it's 9, which forces this to be 8. Makes that 9. 9 eliminates 9 here, so it's 1, which makes this 8. This can't be 1 or 8, it's 4, which leaves this as a 1. And that's how you solve it. Fairly straightforward for a, I think this is called a, well, it's this island puzzle. Maybe it's just an island puzzle, yeah. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.